So I would like to introduce Prateek. Prateek is from DevFolio, and he'll be talking about future of rendering in React.
Hello, am I audible? Yeah. Okay. So hi, I'm Prateek. I work as a front-end engineer at Devfolio, and today I'll be talking about the future of rendering in React. So, building for web has like never been more powerful in 2022, and with React, whether like many people like it or not, has only been growing or rather been accelerating in growth. With like React right now, last I checked, it had like 14 million weekly downloads on npm, which I know is not an exact measure of popularity, but it also has like 3 million plus weekly active users for its Chrome DevTools extensions. And I believe like there hasn't been a better time to getting started in React. So in this talk, we'll be discussing about the rendering patterns that exist currently in React, the problems that they have, and what are the new rendering patterns that the React team introduced with React 18, and how what does the future of rendering look like in React. So right now, like mainly the way we render React apps is like via client-side rendering, server-side rendering, and other meta frameworks like Next.js offers static site generation and incremental static regeneration. So these are the main rendering techniques that we use right now, and then we also have uh, we'll look into all of these, and then we'll also look into the patterns of the future, which are streaming server-side rendering and React server components. Okay, so before we get started with the rendering patterns, let's first discuss about like some of the terminology that I'll be using throughout this talk. So uh, the these are the web vitals that are used to measure the performance of a page. Uh, Firstly, we have time to first byte, which is the time it takes for the browser to receive the first byte. Then the first paint is when the first pixel, any pixel becomes visible to the user. First contentful paint is the time it takes for the first piece of content to be visible for the user. And largest contentful paint is the time for the main content of the page to be loaded. Like you can consider it as the perceived loading time when the whole app is visible to the user. And time to interactive is when the users can start interacting with the app and the app responds reliably to user input. Okay, so first we'll start with client-side rendering. Client-side rendering has been like the most popular or the default way for rendering React apps with Create React App before like frameworks like Next.js and Remix kicked in. So with client-side rendering, you basically just get a bare bones HTML from the server, and the page which contains the JavaScript, CSS, etc. tags, and you download the relevant JavaScript and then render the DOM via JavaScript on the page itself, and all the logic for routing, templating, etc. are data fetching are done on the browser itself. Okay, so we'll look at an example. Like I've created some sort of illustration on how it works. So consider like this is our app. This is the app.jsx file, and we use React DOM.render to render it in the browser. So once on page load, the browser just gets a simple index.html, and it has nothing. It has the div root thing which React uses to render the DOM, and it has all the meta tags or your CSS and JavaScript, etc. Okay, once once the browser passes the HTML, it starts downloading the JavaScript. While the JavaScript is getting downloaded, the users just see a blank page, which is like not good, but that's how client-side rendering works. And once the JavaScript is downloaded, we then render the app. Once the app is rendered, then we have our first contentful paint, and then time to interactive sometimes after that. So even when we have the first contentful paint, most real world React applications would need to uh, fetch some data to like display it to the user. So we have to make those API calls on the browser to display the data to the user. So uh, we fetch the data from the API, and then only then we have the largest contentful paint, so the user can fully interact with the app. So this is how the network graph for looks like. Like we have a pretty fast time to first byte because it's just a static index.html that the server needs to serve, and then we have the first paint when the browser passes the initial HTML, but the user keeps seeing a blank screen until the JavaScript is downloaded and the app is rendered, and the React code is downloaded, code is downloaded, and the browser executes the JavaScript. Then we get the first contentful paint and time to interactive after that, and after fetching the data, we get the largest contentful paint. So what are the benefits of client-side rendering? So one of the most uh, easiest benefit is that it's comprised of like mostly static files, so that it can be easily served via Netlify or anything, any static server, and can be easily served via CDN. And another cool thing is like it allows us to have like navigation without full page reload, so you can do uh, transitions while navigation, so that all stuff is where can be easily done by client side rendering. And also it has like a fast time to first byte, which allows the browser to start loading relevant assets like fonts and CSS and JavaScript, etc. immediately. And regarding the cons, so the number one is performance. The users need to download all the JavaScript before they can see anything. And next is SEO. Although web crawlers can now pass client-side rendering, but they might not wait long enough for the client-side waterfalls to finish, and might like do an incomplete crawling, or like, which is not good. And data fetching also needs to be done on client, so you are dependent on the user's network conditions. Okay, so next we have like this is we have server side rendering. With server side rendering, instead of what we do is, instead of uh, running all the code on client, uh, take the we take the component, we run React's we first fetch all the relevant data that we need to do on the server itself, and then we use React's render to string method to get all the HTML, and then we serve this HTML to the client, which leads to a fast first contentful paint. Uh, Although the user would still need to download client side JavaScript, like to make the page interactive, which is a process called hydration. So I'll just show you with the illustration on how it works. So again, we have the same app. This time, what we do is, in the beginning, we run this code, we run the client's JavaScript on the server, which gives us, we first fetch all the data and then run this code on the via render to string, which gives us the initial HTML, and then we serve it to the client. So if you see, like right now in this HTML, we have all the details for rendering the page. Okay, so we have the title, content, and everything. So once the browser passes the HTML, it leads to a very good first contentful paint and largest contentful paint. The boxes are gray here. The gray part here represents that the user cannot start interacting with the app yet, because we don't have the JavaScript. So how it works is, you tell React ki, hey, this is the HTML that I generated on the server, and here's the JavaScript. So what React does is, it generates the component tree in memory, and instead of generating DOM nodes like we saw in client-side rendering, it attaches the event listeners to the already pre-generated HTML we got from the server. So once that thing is done, we get our app becomes interactive and the users can start using it. So this is how again the network graphs look like. So we have a slow time to first byte because we need to fetch the data on the server and then convert it to HTML, then the browser. But we have a pretty good fast FCP and LCP. So the users at least have like something to see while the JavaScript is downloading. And then on the browser we hydrate the app, which when the app becomes interactive. Uh, so now where do the static site generation and incremental static generation fit in this? So with static site generation and incremental static regeneration, what like for example what Next.js does is it with static site generation it builds uh, it generates the HTML at build time and caches it, and with incremental static regeneration it like caches it per request. So what it does is, since the HTML and the JSON etc are cached, so whenever user requests the page they get the HTML immediately. So with SSG and ISR the time to first byte reduces significantly. So that's the one benefit of these techniques, and that's why Next.js became so popular. uh, but I think like it's not a silver bullet, because you cannot use it everywhere. Like for example, if you want to show render something based on users cookies or something like that, I mean it works best for public pages. That's the thing with static site generation. So with the pros are like, unlike CSR, like SEO is pretty good, because web crawlers like can easily go through server rendered HTML. And since the first contentful paint and LCP are fast, the user at least have like something to see, like they can at least read stuff if they are on a slow network and the JavaScript isn't downloaded yet. The main con we saw is the slow time to first byte, and the other is the time to interactive still remains pretty much the same, because the users still have to download the JavaScript, and still the page React has to generate the componentry and then attach the event listeners. So yeah. So I think like Dan in his discussion of new suspense architecture summarized it really well. The problem with SSR right now is that first you have to fetch everything before you can show anything. So you have to fetch all the data you need to show to the user on the server before you can show them anything. You have to load everything before you can hydrate anything, which means the user have to download all the JavaScript and then hydrate the whole app at once before the app can start being interactive. And again, lastly, we have like you have to hydrate everything before you can interact with everything, which means that the user have to like hydrate is currently single pass in React. So the whole app needs to be hydrated in one go before the user can start interacting with it. So to solve these problems, uh, the React team has been working on the new rendering patterns that we'll be taking a look. So the first one is streaming server side rendering. So what streaming server side rendering means is that first of all, streaming server side rendering isn't something new. It has existed for like 4 years now. It was there in React 16 as well. And what it allows you to do is like we saw, there's render to string method in server side rendering. It added a new method called render to node stream. What it does is that it rendered your app as a front end, as a HTTP stream to the browser. So the browser can start receiving the HTML in chunks while the page is rendering. So it slightly helped improving time to first byte while still giving you the benefits of SSR. It also helped parallelizing requests, like the browser can start downloading the relevant JavaScript and CSS while it is being streamed. So again, like this, Max Stover wrote an article of like 4 years ago about how they used this method at Spectrum and how it improved the performance. So as you can see, like this illustrates it pretty well. With SSR, you have like render to string, and then you get the HTML output, and then you transfer the HTML, and then the client renders it. But with render node to stream, you don't have to wait for it to complete. Like you can start sending the HTML and the browser will start rendering it. Like you give it a chunk, browser will start rendering it, and then another chunk, and then the browser will render it again. So you can like stream it gradually. Okay, so this was before React 18, but with React 18, what the React team is doing is they have deprecated the render to node stream method, and they have introduced a new method called render to pipeable stream. So it has the same benefits of the previous method, but it unlocks uh, a new architecture for suspense, which we'll see later, which allows us to fix the problem like we saw with server-side rendering just before. So what it unlocks is the new suspense architecture, and the new suspense architecture has like two really cool things. First is streaming HTML, like streaming. I'll show you like how it works, but how it is different from the normal streaming. And the other is selective hydration. So first start with streaming HTML. So with React 18, if you wrap a particular component in suspense, uh, it tells React to like display the fallback until the component is ready. So whenever on the initial page load, the user gets the fallback. The in the initial HTML stream, the user gets the fallback that we added to suspense, and once the data for the suspended part we have fetched the data for the suspended part on the server. The uh, server can send that data to to the same stream, and the React sends additional HTML into the same stream with some minimal inline script to pop it into the right place. So again, to how it works. So this is the same app, but let's assume that our comments are very slow. Like comments, the API is very slow and it takes a lot of time to fetch. So we wrapped it in suspense. What happens in initial HTML output is we get a spinner for comments. Okay, and so the browser first renders this, and once like the comments are fetched on the server, we just we just send the HTML to the same stream with some minimal like HTML. Like this is very simplified, like this I use from the React team's discussion, but like this is like a simplified version of how it will work to pop the comments in right place. Okay, and the next thing is selective hydration. So what selective hydration means is like uh, if you have like ever built React app, you must have used like react.lazy. So react.lazy allows you to split the uh, bundle of a particular component from the main bundle, and prior to React 18, code splitting with React Lazy only worked on the client side. So you couldn't do it on the server. You have to like do the whole render to string and then convert the HTML output. But with React 18 and the new suspense architecture, this works. The lazy loading works on the with server side and with streaming server side rendering as well. And what it allows you to do is, apart from the streaming the HTML until the component is ready, it also allows you to like disconnect the hydration part. So even if like for example the comments are very slow to load, you can like start hydrating the rest of the app, so the users can start interacting with the rest of the apps even when the comments are still being streamed. So again, let's see our demo again. So this time we have wrapped, as I mentioned, the comments in suspense. Okay, so when we fetch the page, we get the same layout and everything, and we get the spinner for the comments uh, with the suspense fallback, which is a spinner. So this HTML gets streamed, and the browser passes the HTML, and this is somehow what it looks, and we have our first contentful paint at that time. So let's assume that the comments API is really slow and the server is still fetching the comments. So meanwhile the browser wouldn't wait for it and would start downloading the JavaScript for the rest of the app. So again, let's assume the JavaScript is downloaded and React has like executed the JavaScript and hydrated the rest of the app, but the comments are still loading. Now comments are streamed. Uh, the data relate for comments was fetched on the server and it was sent through the same stream. So the gray again represents here that they are not ready to be interacted yet. So they have like the HTML with in the stream itself. So we can start fetching the relevant JavaScript for the comments, and once the relevant JavaScript is fetched, and we hydrate the comments as well, and again our app is fully interactive now. So the cool thing about this is ki even though let's assume ki the sidebar was also streaming and this was also streaming, and like both of them are streamed, but none of them are hydrated. So if the user like starts interacting something on the sidebar, React is smart enough to figure out ki hey, this person is interacting with the sidebar, so let's hydrate the sidebar first. So React will hydrate the sidebar first, while it will in parallel download the bundle for comments and other things as well. So again, if we see the network graph, so uh, it's again we have a pretty fast time to first byte. We pass the HTML and then we paint, and then like similar to like what we saw, uh, the browser can receive like chunk at any time, and then React will start hydrating it afterwards. So this can happen in any order. Like in this network graph, I have tried to show that this comment gets streamed, and then the uh, JavaScript bundle for the rest of the app comes first, and the comment bundle comes afterwards, so that we hydrate the whole app, and then the whole app is interactive. So now, but so streaming improved the rendering thing significantly, but React team thought that maybe we can do even better. So in 2020, at the end of 2020, they released a new video. They released a new talk with a RFC of something called React Server Components. So what the React team realized is that before React 18, React has been primarily client centric. Like it has like been like that since forever. So uh, what server components allow is developers to take leverage the server more, and they enable like good performance by default. And they also like make it very easy to fetch data in React apps. So how they work is that React Server Components allows you to create components that render only on the server. So one of the benefits of that is that there is zero client-side bundle. There's no JavaScript for server-side components. They only render on the server and then are streamed to the client. Uh, the way you do that is by creating uh, components with files with .server.jsx or tsx extensions, and then what you do is like render the static markup on the server, which has like zero impact on the bundle size. So but keep in mind like it's only perfect for the parts of the app that don't have any interactivity. So what I mean by that is like the React again the React team has given a great example. So as front-end developers, we have to be very mindful about any third-party packages we use, right? So for example, they are using a markdown parsing library which is like 200 like even 63 kb gzipped. And so with server-side rendering, even though you have generated all the HTML on the server and it has no interactivity, and you send it to the browser would still download the JavaScript, all the JavaScript for like the markdown and everything, and then hydrate the app, which is not really necessary. So what we can do with React Server Components is like instead of notes with markdown, we can call it notes with markdown.server.jsx, and the code remains the same. So this way, the markup gets generated on the server and gets streamed to the client, and no JavaScript is downloaded. So again, I mean, you won't want any non-interactive apps. So server components can compose with client components really well. So one thing about that is server components, since they only render on the server, they cannot have any state effects or even event handlers. They are just for like rendering static markups. So what they can do is they can import client components and hand off the rendering to the client components. So what I mean by that is, like, for example, we have the post thing, like same that we have been looking right now. So this is a server component and it renders the post. It it passes the markdown and generates the HTML, but it imports a add comment.client.jsx. So client components will have to use the client.jsx extensions. So the client component has everything, the state, and it has the on submit event, etc. So what it means is that when the page is rendered, the server component would be streamed and the client component will also be streamed, but the client component would also be hydrated, so it can become interactive. Another thing is they can access the backend directly. You can, like, literally access your backend only resources directly in your server components because they only run on the server. So that's one advantage. And they have many other features as well, like automatic code splitting. Like we saw with react.lazy, you have to, like, even on the client side, and you have to manually remember to use react.lazy. What server components do is, like, they treat all client imports as like potential code split points, and since you will know on the server like which component you are using pretty early, so you will download the JavaScript only for that component. And also they can preserve client state when reloaded. So what this means is, like, if you want to, like, reload something, like something got updated and you want to reload, so what server components do is, like, they can be reloaded without reloading the page, and it preserves the client state. Even the focus and the animation, they can keep on happening while the server components will be refetched. Like, the way it works is because it uses a system that is richer than HTML. They don't use HTML but some other method. Okay, so lastly, again, let's see our app, the again with server components. But keep in mind, this time the sidebar is a server component, that's why I have named it this way. The post is also a server component. The comments in navbar are still client components. Okay, and we have wrapped both post and comments in suspense. So one thing I forgot to mention is that server components work with suspense out of the box. So all the features we saw with streaming SSR just work out of the box here. So again, we get the HTML is streamed. This time we get spinner for both the post content and the comments. Uh, so again, the browser passes the HTML, and the navbar and the sidebar the user can see with the suspense fallbacks, and the user can start downloading once these are streamed, the user can start downloading the app, the JavaScript for hydrating relevant client components. So in our case, the navbar was a client component but the sidebar wasn't, so we download the necessary JavaScript to hydrate it. So let's assume the navbar gets hydrated and the post and the comments also get streamed in. So now we download the necessary JavaScript for comments, and yeah, the as you can see, like, we didn't need to hydrate the sidebar and the post content because they were server components and they don't need any hydration. They just render on the server and then stream to the client. So yeah, that's mainly it. That's the that's what the React team has been working on. That's like the future of what rendering in React looks like. So I mean, you might ask, like, when can I start using these features? So the answer is, like, not yet, because you cannot use these in production apps right now because most of the APIs are still not ready, and server components, like I mentioned, are still in alpha, so they aren't really stable yet. But the React team has mentioned, like, the things we saw, like the streaming SSR and both server components rely on suspense for data fetching. And suspense for, as of today, suspense for data fetching, what React team plans to do is, like, release it as a minor version, and it will have like a bunch of things like React IO libraries like React Fetch, which then data fetching libraries could use internally to give us the abilities. And it also has like built-in suspense cache and server components like we saw. So this will be done after, like, once in a React minor release. And then also one thing you should keep an eye out is the layouts RFC by the Next.js team. They are also themselves calling it the biggest update to Next.js since it was released. So it is built such that to take advantage of the React 18 features that we just discussed. So should definitely check it out. I think they might announce something in the October conference that they are having. So yeah, that's mainly it. And these are the references that I use for this talk. The majority of my talk based on the new suspense architecture discussion by Dan Abramov, and you can also check out the server components RFC and talk on the React.js website, and the Next.js server components demo. And these are a couple of articles which I found interesting and used a couple of things in my talk. And then you can also check out the demos, as I mentioned that the demos are also kind of like shaky, they don't work perfectly, they use a bit of hack, so that's why I didn't show the demos here. So you can check out the demos, you can check out the code, how it works. Yeah, that's it. Any questions?
Hey, thanks. Great talk. So, a couple of questions. You mentioned, from what I have read, I understand that even when the selective hydration is taking place, if the user interacts with some particular component, the React will prioritize
Yeah, that's what.
hydrating that first,
Yeah,
right?
that's what.
So, a question over there is it possible that, let's say that a particular, this is a very edge case I'm just thinking about, is it possible that when the streaming HTML has started, and one of the components, like because we are code splitting everything, so not each bundle will have React, right?
No, the HTML, like the streaming happens for HTML only.
Yeah, I got that. So when we are code splitting, the bundles, because the bundles have been code split for each component now,
Yeah.
is it basically, is it possible that the browser tries to hydrate a component even before it has downloaded React itself?
I mean, it's not possible. Like, you need to download React. So, I mean, React would be part of some of the main bundle. React would be downloaded, then the component code would be downloaded, then only the component can be hydrated. You still need React to download React.
Okay. And second question was, the server components, I think the problem that this solves is even with streaming, server-side rendering and all, you are basically still at the end of the day rendering the app on the server and the client. I think this is directly solving that. Uh, I just wanted to check if you had any views on what Astro is doing with the island architecture. Is it similar in some ways to that?
Yeah, I mean, I have heard about Astro. I never got to try it, but yeah, I have seen that they also do the same thing, that you can hydrate some components and uh, no, and even like hydrate only when you scroll to them, those kind of things. So I guess it's similar, but like server components also have like these other features that they can reload while preserving the client state and those kind of things, which I'm not sure if Astro has them.
All right. Thank you.
Anyone else?
Okay. Thank you.
Thanks, Prateek. Thanks for the insightful talk.